the next two talks are going to be dealing with different ways of handling OpenWrt. There's some like debate as to, when should you fork, when shouldn't you fork, should you ever fork? So I think that it's interesting because the next two talks actually handle it slightly differently. So Beta is going to talk about Project Turris and the Open Router with OpenWrt. So.
Thank you very much. I hope you hear me. Until now, all the talks were were from the core developers and prpl Foundation and so on. Right now, I would like to take the view to the other side and talk about how we are using OpenWrt in our project. We are not directly involved in OpenWrt, so hopefully this will be another view. If you are interested in seeing some open source hardware and what you can do with it, then this is the right talk for you. So at first I will start something about the company I'm coming from, because this is something I think unique in the world of OpenWrt. We are actually the operator of the .cz top-level domain. So if you have a domain with .cz at the end, we are taking care of the infrastructure for you. As you might imagine, we have a lot of DNS servers around the world. We are big on DNS, DNSSEC and related stuff, also other networking things. And why would we care about OpenWrt? You usually don't use it on the routers that we use in our infrastructure. The reason is, well, let's continue slightly. This is also strange, maybe. We are not-for-profit company. And what we do with the money that we get from the domains is, of course, we run the infrastructure, but we then try to give the money back to the community, what is left. And we try to make projects that are good for the internet. So this is the reason why we got into the work with OpenWrt. I will explain it later. What we do, for example, we are developing a BERT routing daemon. Maybe you know it. Many, I think more than half of the large exchange points around the world use BERT. We are also developing not DNS server. This is an authoritative DNS server. High performance, I think it's right now the fastest in the world. This year we will also have not DNS resolver, which we have already discussed, might be interested for the OpenWrt community. We are interested in DNSSEC, securing the DNS. So this is why, for instance, we are developing DNSSEC plugins for browsers so that you can really see the status of DNSSEC on the domain where you are from your browser. And we do a lot of other security-related research. We also run the Czech National CERT team. So if there is some let's say computer crime involving some international stuff, then our national team takes care of communicating with the other national teams and so on and coordinating it on the national level. And what is very important, everything we do is open source. So what I've mentioned here, everything is open source. You can find the source code, and we release everything. We really believe that open source is the way to go. So what is Project Turris? What we do and why we do it? This project is related to security research in SOHO networks. As I said, we have a huge infrastructure when it comes, we are really used to dealing with large networks and so on. Our security research was really focused in this area. But then we decided, well, what about the home users? They also need to be somehow protected. Someone should also take care of this security of these networks. So why not make a project in this area? And we decided to give, let's say, security probes to volunteer users, and to monitor what is going on on the edge of the internet and their network. We are not interested what is going on inside their own network, but on the edge, what kind of stuff is trying to get in, what is getting out, and so on. So this is one of the things. And we also wanted to put into it some kind of distributed approach, so that not only looking at what is going on at one user, but when you have information from many users, you can very easily see some anomalies. You can see this user does something strange. Why is he trying to connect to so many SMTP servers, much more than any other? And then you find out, okay, he has some malware there in his network and he's trying to send spam or whatever. So if you have a distributed network of probes, it's much more easier to do this stuff. And also many users, the Soho users, do not know anything about computer security, or not much. So if you can take this, somehow centralize it and help them with it, then it's really beneficial from our point of view. And well, what's the best way, or the best point where you can do this security stuff? It's in the router, because this is really the point where the internet and your network meet. And this is where you can protect the network, the whole network, including the mobile phones and whatever. And this is also the point where you can monitor the stuff and see what is really going on. So router as a security probe. And also this, as a side, one side idea of this project was to try to show the general public that this is possible to have something better in their home routers. Not the years-old software that is usually shipped with their routers, but something new, something better. And as I said, we are very interested in DNSSEC. DNSSEC is nice, it's cool, but if the end user doesn't have it, then it doesn't work, it doesn't benefit him much. So we wanted, for instance, to show it's possible to have DNSSEC in the home router. It's possible to have better IPv6 than you normally get from these boxes, and so on. Okay, so what's the current status? We started this project in 2013, and the original idea was to buy some devices, flash them with OpenWrt, put our own software on it, and give it to the users and start collecting data. But we soon found out that for some of the methods that we really want to use on this device, we cannot find good enough hardware. And because we wanted to distribute something like 1,000-2,000 probes, there were no manufacturers that would be really willing to talk with us about some customization and so on. So we decided to build our own boxes. I will show them later. And this, of course, took us some time to develop them. But in 2014, we distributed 1,000 our own routers to the end users. They get it for free. They just have to run it for 3 years, and they have the box completely for free. They just have to allow us to monitor their network. We do it very, let's say, cautiously. We sign a contract with them. There is a specification of what we can monitor, what we cannot monitor, and whatever. And this year, we are distributing a second batch of these routers, slightly modified with some new features, but essentially it's the same. Some highlights just from what we have seen, or what we are doing in the network. I could show you much more, but this is just what is related to OpenWrt. What we are doing, one of the important features is that we are doing automatic updates, unattended updates. Because one of the problems with Soho routers is that usually the user buys it, plugs it into the network, configures it, and then it runs 5 years without any patches, any new firmware, whatever. So once you discover a hole in this firmware, you can attack tens of thousands devices at once because they are unpatched. So the thing that the way we are trying to solve this is to do updates in which the user is not involved, because it's not enough to put the patches outside to the internet. It's not enough to have a box in the configuration interface of the router which says there is a new update, because nobody goes to this interface, so he wouldn't know about it anyway. So the only way, from our point of view, is really to push the updates there and just update it. And we already did something like 10 large automatic updates. We even switched major versions of OpenWrt seamlessly, let's say. Of course, it requires a reboot if you change the kernel, but it's done in a very intelligent way. We have successfully caught malware in many cases in the user's LAN using different methods. And we have even found, this is just one point, we have found a botnet that is trying to attack the boxes on the internet using telnet, which is comprised almost uniformly from ASUS routers. This is currently, we have seen at least 20,000 these routers, which are trying to attack telnet using the same set of passwords. And so it seems that they are really run from one center. So other output from the project, as you can see, we have a distributed network of about now 1,000, 2,000 probes. So we can collect data and put out some statistics. Some of the statistics are global. We publish them on our website. So you can, for instance, see what is the IPv4 to IPv6 ratio for our users. What are the most attacked ports, because we collect also firewall logs from these devices, and so on. We also give much more statistics to the individual users. So, for instance, they can see some estimation of their bandwidth. This means the maximum speed of download or upload they have seen during, for instance, a day. So they can estimate if what their ISP is giving them is really what they are using, or if the ISP is somehow lying. We also publish publicly a gray list of IPv addresses that we see in the firewall logs. When we see it for many users, then we can construct such gray list, and you can benefit from it. Also our users benefit from it, because the traffic that is going between the gray listed IP addresses and your network is somehow suspicious, and we have in this way detected also some malware infestations where someone was sending data to some Chinese IP address that was trying to connect to many other boxes. So it was obviously some kind of successful attack, and we have been able to mitigate it by contacting the user. There's also port trend, which is something that shows you what ports are, how the number of attacks on different TCP and UDP ports changes with time. So when you, for instance, see a spike on SSH in your firewall logs, you can have a look at this output and see, okay, it's not only me, it was seen also elsewhere, and so on. Everything you can find here, www.turris.cz. There are many graphs, charts, and other output. These are just examples of the outputs. I will not comment on this. It's just very nice pictures. Some of them. This, unfortunately, you can only see as a user. It's how you use different speeds during the day, that I will not get into detail. We don't have time. So how does the box look like? This is the first generation. This is the second generation. The most visible difference here is the USB 3 port we have added. I will tell you more details later. Here are the highlights. There is a P2020 dual-core processor. It's PowerPC running at 1.2 gigahertz. So you can see this is really a different box than what you normally buy in a store for $20. There are 2 gigabytes of RAM in a SODIMM slot. The reason why we need so much RAM is because some of our methods use a lot of data. They have to be able to look back into the past, short past, to compare the data, and we need to store the data somewhere. And so we decided to put there a SODIMM slot, and the 2 gigabytes is the lowest number you can buy now. So even we would be happy with 1 gigabyte, but well, there are 2. But there are users who really use it, so not many, but they use it. And what is also interesting, we have 256 megabytes of NAND flash, which means that we have a lot more than you normally have in a router. And I will talk again later about this. This means that there are virtually no constraints when it comes to installed software for us. So we can really be much more free with using the space in our router. Yeah, and there are some other cool stuff. For instance, there's a debug console with FTDI chip included. So you just plug in a USB cable to your device, and you can debug it on a serial console. So this is really great. I have used it many times when I was so lucky to disconnect from or reconfigure my device so that I wasn't able to connect back. So this is very helpful. So now to OpenWrt. How we use OpenWrt. We decided to fork OpenWrt, and we call it Turris OS to make it simple to remember to our users. But there are not so many changes. But why we did it and what we did differently. One of the main reasons were the automatic updates. We really didn't want to use the setup where you have squash fs, which is read-only, and then the rest. We wanted to have the full system run out of packages that you can update anytime. So something more akin to what you have in a normal computer. So we changed this setup, and this was one of the main reasons. There are other reasons. We wanted to change some of the basic software. We, for instance, didn't want to, we wanted to use DNSSEC. We wanted to have DNSSEC enabled in the router, and this is why we had to exchange the DNS resolver and install Unbound. We also use OpenSSH instead of Dropbear, simply because there are some features of it that we require in our software. And for instance, we also added a second user interface. It's called Turris. It's a very simple wizard-like interface, which really takes you through the few basic setup steps of the device, which everybody can do. Even I believe your grandmother might be able to do it. Well, maybe not your grandmother, but it has the advantage that it's very simple and it doesn't let you set up anything which would be unsecure. It forces you to use a strong password for Wi-Fi. It forces you to set up the password at all. It doesn't require. It cannot let you use admin the default that many boxes have and which can be exploited and so on. So these are some of the changes, and we also wanted to have a final control of what we released to the users. We wanted to update some parts, but leave other parts untouched and so on, because we have to, as you can imagine, if you push your changes to 1,000 users and they cannot do anything about it, you have to test it very carefully so that you don't break 100 devices. So we really wanted to have fine control about it, of this. So how we work when it comes to OpenWrt. We are trying to follow upstream. Of course, there is some delay. When I created this presentation, many of my colleagues asked me to mention that the SVN plus kit that OpenWrt is using is not a good tool for outside sources. It's it's very hard to work with it. When we had to incorporate some changes, it's much less convenient than when you just work with Git. So if I could say that I have to say one thing that I would like to see changed in OpenWrt, it would be to go to Git and only Git.
Yes, we agree.
I'm happy that I'm not alone.
Sorry, this is on. Can you write an email all together to openwrt-hackers@openwrt.org? If enough people of you do it, we'll probably maybe doing it or not.
Cool. No problem. Let's do that. No problem. So I'm quite happy that this was so well received. Well, we try to push to the upstream, but well, with mixed success. There are parts of our code that really doesn't make sense to push into the upstream because, for instance, we use Python for some of our development, and Python is such a huge beast, even on OpenWrt, that you simply couldn't squeeze it into the basic image, which has 8 megabytes, and so on. Also, there are, as was already mentioned before by Stephen, there were some problems with getting feedback when you push something to the upstream and so on. Hopefully this will change now. We are also learning how to approach this, and I see this opportunity as a great way, or this meeting as a great way to really get into contact and maybe get personal contacts so that this stuff can be done much more easier and without so much trouble. So when we are ready, we test both on machines and on people. We use Lava for our automated tests. We have a testbed of several routers, which we can automatically reboot and refresh and whatever, and try new software on them. We are considering board farm right now, but we are still working on Lava. And what we also do, we use some kind of tiered distribution of updates. So at first, these new updates go to the development group, just to the developers. Then it goes to a slightly larger group of people, where also most of the management of our company is. So you can imagine the pressure on the developers when they know that if they push this and it breaks something, it will break their boss's router. And not only his boss's, but his boss's wife's router. So this is really much pressure on the developers to really take care about what they submit. And after that, we push to the general public, but then usually it's already very well tested. So what we can offer, I have mentioned that we have done some changes to OpenWrt. So what we have the updater. This is right now it's a very huge shell script. We started with a very small, easy shell script. Now it's very long, so we are thinking about rewriting it. But it's a system that really takes care about the automatic updates. One, it checks our repository of packages every hour, and if it finds something new, it can very well, let's say, intelligently decide what to download, in which order to install it, and if it needs to be rebooted before some installation and whatever. But it's pretty intelligent right now. It's been developed more than a year, and we are running successfully. So it's something that might be interesting for OpenWrt community. We have, for instance, also created something we call a majordomo. It's an Lucy application which monitors the traffic between your LAN devices and the internet and gives you some kind of statistics. It's very interesting if you, for instance, have a smart TV at home or a NAS box or whatever, to see what kind of IP addresses and servers these smart devices are talking to. There were some problems with some very smart televisions, even smarter than everybody thought, which tried to send data from the LAN network to their manufacturers and so on. And this is why we decided it would be nice to have an overview of what your smart devices are doing. But you can also do it for if you share the connection with the neighbor and you want to split the costs. You can use this application for it as well. And this is pure Lucy, so it could be integrated into OpenWrt without much trouble. Another thing we have done, we have created a netconf interface for UCI. It's called NUCI, very innovative name, and we use it in our own stuff. It's very simple translation of the UCI tree to netconf. But we have it tested. We use it for for a small desktop application. We have a prototype mobile application, and we use it in our own web user interface. So it works pretty well and could be adopted very, very easily. We also have gained much experience with DNSSEC in Soho routers, so this is also very interesting. If you would like to include this, and we can offer some more experience with the hardware we have. So if you are developing on a similar platform, you could benefit from our knowledge. All the code is on GitHub, so go there and you will find it. And now to the last part of my presentation. As you can see, I have a very nice T-shirt. And this T-shirt has this logo, Turris Omnia. And this is our new project. This is a project where we decided, because there were many people asking us, could we get this router also if we are not in Czech Republic and we don't have the opportunity to be part of your project? Could we get this router? And we said, okay, sorry, no, we found it from the Czech domain, so we cannot give it to you. So we decided to build something new, something that we could really offer to the general public. And this was previously called Lite, but because of the features, so many features that were added to it, we decided it's not Lite anymore. So we decided it's Turris Omnia, because Omnia means everything. It can do everything for you. Yeah, in many things, it's more slightly already a hybrid between a router and a small CPU or a small server for small PC. So this is the first Turris that will be publicly available. We are just working on it. We are lucky we don't need to make profit on it. We have already spent so much money on it that it doesn't matter. We just no, seriously. There are so many developers that we have to pay to do this. So, but what we need to pay for is the hardware. We need to pay for the chips. We need to pay for the manufacturing. So we have to give it for some price, but the price doesn't have to be so large, because we don't need to make profit on it. The router is designed for geeks. We are geeks, and we decided that we cannot build a device we don't understand. We wanted to build something that we would like to have at home. So it's really built for geeks, and it's built for OpenWrt. This is our main target, OpenWrt. We are not interested right now in anything more. And it will be open hardware as well as all the stuff we are doing. This is the box. This is the board. I have, where I put my, here it is. Yeah, it's here. It's not a 3D model. It's a real board. This one doesn't work, but well, the developers wouldn't give it to me if it worked. So yeah, right now we are in prototype stage. This is the first prototype, and we already have several of them running, and everything seems to work. I will go through the details very quickly. So it's based on Marvell Armada 385, running at 1.6 gigahertz dual core. It has 1 gigabyte RAM, and what it has is eMMC memory, 4 gigabytes. So it's huge when it comes to the OpenWrt terms. It's really huge, and this is what we wanted. We wanted to have no constraints when it goes to installing software. We are even thinking about providing a container built into the basic image, which could even have some, I don't know, Ubuntu or Debian or whatever, so that you can have a virtual server inside your router. Because this is the way we think you can separate what the user needs, what he wants, and the router, which he shouldn't touch so much, not to break anything. So this is how the Ethernet is organized. Because the SoC has 3 Ethernet lines, we use 2 to connect to a switch chip, which then operates the LAN, and there is a dedicated Ethernet line to WAN, and there is also SFP. If you plug in SFP, SFP gets connected. If you unplug it, then you use normal metallic WAN. So I think it's very interesting, even for ISPs. There are some other things. I will not go into detail. I see that Eric is already nervous. Sorry.
It's not your fault.
What's interesting, we built in battery-backed up RTC chip. This is because when you use DNSSEC, you need correct time. There is a chicken and egg problem with DNSSEC and time, and how to get the time with verifying that it's really from.
Time you don't trust the network.
Yeah. Well, at first you set it up, and then the battery backup takes care of it. Interestingly, also, there's a crypto chip which is used for better entropy in random number generation. So if you generate your certificates and whatever, you get a good source of entropy. And there's some other stuff. We get RGB LEDs programmable, so you can even do stuff like, if you know Knight Rider, this is the first thing, almost the first thing that we have done with the box once we found out that it lives. We had to play with it somehow, so this is what you can do. But it can do much more than this.
Thank you.
Sorry.
We're going to have to move on. I'm sorry.
Sorry.
Okay.
It's very fast.
Okay.
We will have an Indiegogo campaign in about a month, so just follow us, and the routers should be available sometimes in 2016. The price will start about $100. We are not. It depends on the amount we can sell. Obviously, if you buy the chips, the more you buy, the cheaper they get. Everything else you can find here, Omnia Turris CZ. Finally, here we are. We love OpenWrt, and we would like to cooperate more. We would like to push more stuff into the upstream and really cooperate. So talk to us. We will be here. I am looking forward to the social in the evening and so on. So we are here for you, and thank you very much for your attention.
Thank you.